Question 4. A. Ammonia gas reacts with HCl gas to produce NH4Cl solid ammonium chloride. As shown, ammonia plus hydrogen chloride is giving ammonium chloride solid. Draw a diagram to show the ionic, covalent and coordinate bonding present in a formula unit of ammonium chloride. Here in ammonium chloride, nitrogen is making 3 covalence bond with 3 hydrogen, which is ammonia here, and this ammonia will make a coordinate covalent bond or a dative bond with hydrogen. Here the nitrogen with lone pair of electron will donate electron to the hydrogen and will form the dative covalent bond. And then we will get ammonium ion. This ammonium ion will form an ionic bond with negative halogen chloride. So there are 3 covalent bonds, 1 coordinate bond and 1 ionic bond between ammonium and chloride ion. B. An exothermic reaction occurs when ammonium plus is added to OH minus or hydroxide minus. So 1. Identify the type of reaction. Here ammonium ion can donate proton, so it is an acid, and hydroxide ion can accept proton, so it will be a base. So here the reaction between an acid and a base will definitely an acid-base reaction. 2. Construct an ionic equation for the reaction of ammonium ion and hydroxide ion. So here ammonium ion will react with one hydroxide ion and will give ammonia and water. C. Substitution reactions of ammonia and hydroxide with halogenoalkanes both involve a lone pair of electrons. 1. Name the role of ammonia and hydroxide in this reaction. So in this case both ammonia and hydroxide has lone pair. In ammonia nitrogen has a pair of electron, and for hydroxide with oxygen there is a lone pair of electron and a negative charge as well. So we can say both of them are nucleophile. Part 2. Suggest which species, ammonia or hydroxide, is more reactive during these reactions. Explain your answer. So here we can see ammonia has a lone pair of electron and hydroxide has a lone pair and also a negative charge in it. So definitely hydroxide is more reactive as it is negatively charged particle, which will be more attracted to the halogenoalkane or the carbocation intermediate. For example, if we take ethyl bromide, here carbon will achieve a partial positive charge and bromine will have a partial negative charge because of the electronegativity or polarity differences between carbon and bromine. So here the nucleophile, which is hydroxide, will attack the positively charged carbon and will give an intermediate compound. From here we will get ethyl hydroxide or ethanol and bromide ion. So here for the negative charge of hydroxide it will be more reactive. Part D. When 2-bromo-2-methylpropane reacts with hydroxide ion, two mechanisms SN1 and SN2 both occur. The SN2 mechanism has a slower rate. Figure 4.1 shows the reaction pathway diagram for SN1 mechanism. Sketch a graph on figure 4.1 to show the reaction pathway for SN2 mechanism. So here in the given graph, which is SN1, we know that SN1 reaction has two steps. In the first step, it will form a carbocation, and in the second step the nucleophile will attack the carbocation and will give the products. So for these two steps we are getting two humps, and for SN2 it's a one step mechanism. As it is mentioned in the question, the SN2 mechanism has a slower rate, so the activation energy will be higher than SN1. That is why we have given higher activation energy here and one slope for one step reaction. E. 1. Complete figure 4.2 to show the mechanism for the SN1 reaction that occurs when CH3CHBr C2H5 reacts with ammonia to produce this compound. Include charges, dipoles, lone pairs of electrons and curly arrows as appropriate. So here we can see it is a butyl bromide, 2-bromobutane. Here the carbon will gain a partial positive charge and the bromine will have a partial negative charge, again because of their electronegativity and polarity difference. So here the ammonia, it will act as a nucleophile with lone pair of electron on nitrogen, will attack the partially positive charged carbon. Now what will happen? We will get this intermediate with a positive charge on nitrogen. So this positively charged nitrogen will take the bonded electron between nitrogen and hydrogen towards itself, and we will get this product, butane 2-amine and hydrogen bromide. There will be a lone pair on top of nitrogen here as well. Part 2. Identify the inorganic product that forms in the reaction in figure 4.2. So here we can see we have got an inorganic product, hydrogen bromide. This hydrogen bromide will react with the ammonia present in the mixture and will give ammonium bromide. So the product will be HBr plus ammonia is equals to ammonium bromide. Part 3. Give the systematic name of the organic product CH3CH NH2 C2H5. So here is the structural formula from where we can see there are 4 carbon atoms, and on number 2 carbon there is an amine group here. So the name of the product will be butane 2-amine. F1. Complete table 4.1 by drawing the structural formula of the intermediate that is formed when 2-bromo-2-methyl-propane reacts in SN1 reaction. Table 4.1. Structural formula of intermediate in SN1 reaction. So 2-bromobutane, here is the carbocation given for 2-bromo-2-methyl-propane. This is the structural formula. We will get this carbocation. Here bromine will be negatively charged and the carbon will be positively charged. So we will get this carbocation which is a tertiary or 3-degree carbocation. Identify the halogenoalkane in table 4.1 that has the greater tendency to react using SN1 mechanism. Explain your answer. We know that alkyl groups are electron donating groups and have positive inductive effect. Therefore, 3-degree carbocation which will have higher alkyl groups, here you can see here it has 3 alkyl groups attached to the positively charged carbon, and for the 2-degree there are 2 alkyl groups. So 3-degree carbocation is most stable with higher number of alkyl groups. So we can say that 2-bromo-2-methyl-propane, which is a 3-degree carbocation, has the greater tendency for SN1 mechanism. And that's all. Thank you.